So it turns out the only mistake I've made there was actually just in the estimating at the end. 2.3 is absolutely fine if you're sticking in the calculator. I think what I did was I square rooted the g at the wrong point, but no, well, if you're interested you can go back and work it out, but this is fine. V ends up as 2.3 as it should, or 2.37 to 2 decimal places. Assuming that B does not hit the pulley, find the greatest height that B reaches above its initial position. So, this is what happens then. Here's the pulley, and let's just think about B. So here's B all the way down here. First of all, it's going to move 2 meters up, and it's going to get to this height. And when it gets to that height, well, it started at a speed of 0, the same as A, and it got accelerated in the same way that A did, so it's going to be moving with a velocity, which I'm not going to call u because it's the initial velocity for the bit that we're interested in, of 2.3. Now, when A hits the ground, this is where we need to use a bit of sort of common sense about this. Imagine what would actually happen if A hits the ground. This string is going to go slack, so the tension in the string is going to disappear. So this is going to be the same as though we've got a particle B here that's moving vertically with a speed of 2.3. Oh, doesn't quite fit on the page, sorry about that. And it's as though there were no string and no pulley there at all. So what we're going to do will look like this. We've got a particle B moving under gravity. Gravity's pulling down. What's that? Acceleration equals gravity, which equals minus 9.8 in that direction, meters per second. Initial velocity is 2.3, and the question they're asking us is the greatest height that B reaches above the ground. So B is already above its initial position. So B is already 2 meters above its initial position, and we need to find out the distance that it travels. So it's going to go up and then stop. So eventually up here somewhere it's going to have a final velocity of 0. So U, B, A, S and T. And now obviously again, if you were writing this you would keep going down the page. I'm scribbling it all over the place to try and fit it on the screen. So U equals 2.3, V equals 0, A equals minus 9.8, S is what we're trying to find, time we don't mind. So V squared equals U squared plus 2AS again, so V squared equals U squared plus 2AS, 0 equals 2.3 squared plus, minus 2 times 9.8 times S. So S equals 2.3 squared divided by 2 times 9.8, which is 19.6. I'll feel free to fast forward while I stick that in my calculator. 0.269 is what I've got. That doesn't seem right, does it? No, that's because I've missed out some brackets on here. Oh, it does seem right, okay. And then we're adding on that initial 2 meters, so that seems suspect to me, but again, we'll check the answers, and if I've got it wrong, I'll pause the video, work it out, and then come back to you. Oh yeah, 2.29, well I've got 2.27, so I think there's just a rounding error in there. Yeah, I've used 2.3 here, so if I'd used 2.37 for my answer to part B, then I think that rounding error would clear itself up. So that is question 1.